Hello, my name is Dillon Howe, and I'm going to be doing my presentation on SQL injection. Um, so a little introduction. SQL injection stands for Structured Query Language Injection. And structured query language is usually used for constructing databases, accessing databases, and managing databases. And SQL injection is typically used for stealing information from databases to attack databases. And it's typically caused by poorly formatted SQL code, and it's typically prevented by sanitizing inputs. So some motivation objectives behind this project. So Open Web Application Security Project, OWASP for short, lists injection-based attacks as number 3 in terms of security vulnerabilities, where failed cryptography is number 2 and broken access control is number 1. And SQL injection is actually still common today. In fact, there's even a SQL Hall of Shame that lists all the SQL injections that happened and caused database leaks. And typically whenever a database leak occurs, whether it be through SQL injection or otherwise, typically millions of records are leaked to the public during a breach like this. And these are all reasons to handle this vulnerability. So a little background on SQL injection. SQL injection occurs when malicious SQL code is input into a query meant to access the database, and it can usually expose either the query itself or it can expose everything in the database. There's different types of SQL injection. There's classic SQL injection, which is basically just the standard version of SQL injection, where malicious SQL code is sent in and information is returned. And that's just a general definition of SQL injection. There's also blind SQL injection, which is basically just classic SQL injection, but the user doesn't know anything. And so when this method of SQL injection is used, typically what occurs is the query itself is exposed and then the database is exposed. Although this method is very time consuming to do. And then there's also compounded SQL injection, which combines SQL injection with another attack method. So Python SQLite 3 was used to create the database and send queries to the database. So allow me to demo that right now. So here in the main function, we called the database create and the login. But if we check here, the database has already been created. Browse data, we've got 3 users and 3 passwords. We're initialized right here. This is less important than the actual login, which is basically just creating an interface for the user where when they click the login button, it sends information to read from the table. And we have 3 implementations. And if I run this, we can see the good implementation, which uses question mark queries. And if we type in, say, Dumbo123, login, it returns Dumbo123. If we don't input anything, it doesn't return anything. And when we do, say, an SQL injection, which I believe is, it won't do anything. But if we switch the code that's being used to the awful version, and then start this, you can see that we can type in Dumbo123. Nothing. And if we type in this SQL injection, you can see that we get the entire database in return. So findings, I found that it was actually very difficult to create SQL injectable code. Even the moderate version of code I used was very difficult to SQL inject into. In fact, usually it would just throw an exception. And with the moderate code, it would expose mostly the SQL query rather than just the database itself, which is still insecure, but it's still better than leaking the entire database. SQL database leaks can be very harmful. You saw that when the entire database was leaked to me in the terminal. And you saw that it wasn't very difficult to perform. All that it requires is that the database is improperly set or accessed. So it's very important that we prevent SQL injections, as they can be very detrimental to cybersecurity. And here's some of the references that I used.